Hi there, welcome to part 2 of building generic data structure in Go. In part 1, we built a linked list, which I'm going to link to this video. In this second part, we are going to build a queue. Queue is a simple data structure that means the first in that joins the queue is the first thing that comes out. I'm going to take a different approach in this screencast by using the diagram software here, where I'll be drawing out the diagram, then translate it to code. That way, for beginners, you learn how to translate your idea by drawing it out into code. The first thing I'm going to start with is to draw the queue. So like I said, this is the queue. So imagine yourself joining queue for ATM or whatever, right? This is the queue. Now, the items in the queue, there can be anything. So let's call that, like we're going to have a list of items in the queue. Right? Simple idea so far. So I'm going to just delete this for now. So let's create this container queue. I'll say go mod init generic examples, make dar queue and touch queue slash queue.go. Fantastic. So let's open up the queue file. Right, so package queue, what do we want to name this? Let's create a type called queue this time around and introduce generics. The reason why I'm naming it just queue is because we have the package queue here, and it doesn't matter because we are not exposing this data structure to the outside world. So if you are accessing the queue from outside this package, you won't have to worry about this because we are going to have a way for you to create an instance of this data structure without exposing this one. This is now the translation. So we have this queue here. How about the properties? To join the queue, we're going to have, let's call this back. For this back will be an int that we use to track how people join the queue. And of course, when people join the queue, they exit at the front. To implement a queue data structure, you can use a linked list or an array, which I'm going to do here. I'm going to use an array because we have studied linked list last time. It would have made sense just to leverage that, but I want to show you a different approach. So we have the back and the front. So let's go ahead and add it. Back, int, front, int. How about those items that will be on the queue? So let's make it items of type. Like I said, it's going to be an array. So this is Go slices. Slices are just an array. They are wrappers on an array. So a slice describes an array. This is our queue. So we have it. Next step is how do we create an instance from outside of this package? So let's create a function. New. We need to introduce generic. Returns what? A queue. And this is so items. Let's allocate some memory so we can start with any size we want. So for now, I'm going to start with a slot of. So how long is our queue, which is the capacity for now. So let's start with just 10 item slots. The front will always be pointing to the elements that enter the queue first. We make it 0 by default. Then the back will be -1. We set back to -1 because when there is nothing in the queue, back should be -1 so we can do anything we like. Like if someone wants to dequeue, which is a process of taking something from the queue. When the queue is empty and you want to take something from the queue, that should be an error. We have the way now to create an instance of this queue from this package. Next step is how do we add items to the queue? First step is to bring an item like this. So we are adding this first item. The process of adding an item to the queue is called enqueue. Let's go ahead and create a function called enqueue. This is going to be a method on the queue object. I will be naming it this, which is a reference to the queue. And this is the method name itself. The item we want to enqueue will be of type T. At the moment, we're not returning anything. When you add an item to the queue, what happened? We need to change the value of back. But before we do that, What happens when the queue is full? We want to check for that first. How do we know if the queue is full? If the queue is full, the value of back will be equal to the length of these items minus 1. So we can say this dot back, if it's equal to the length of this dot items minus 1, then the queue is full. What do we want to do? We have some options here. One is to return an error. Another one is to expand the queue. I will go ahead and expand the queue. What does it mean to expand the queue? You basically create a new allocation entirely. I will create a new list. Make slice of type T. What will be the size now? Let's make the old size times 2. So we just double the size. Then we copy over the items from the old queue, from the old list. I have a typo here. We copy over the item from the old list to our new list. Then we set our list now to the new one. So when our queue is full, we create a new allocation, copy item over, and set the item. At this point, we can increment the value. When we put new item, the value of back will be, now the value of back would be 0. So at this point, the value of back is 0. So we can go this dot back plus plus, then we add the item at that index. And that is the implementation of enqueue. How about the process to dequeue? If we add more items here, we add another one. This, of course, will increase to what? 1. We add another one. You see, we are not changing the front because the front is for dequeuing. We add another one. Back is now 2. When we want to dequeue, at this point, I can just move this here, move this here. Remember, by default, front is 0. That means we can dequeue and increase the value of front. To do that, let me copy over this structure. I'm going to delete most of it, rename this to dequeue, just to save us some typing. But there's something that we need to be mindful of. What happens when the queue is empty? We need to check for that. How do we know when the queue is empty? If you look at it, if the value of back is -1, then the queue is empty. Or if the value of front is greater than the value of back. How? Imagine we take this one off, this will be 1. We take another one off, this will be 2. When we take another one off, this front will be 3. And the value of front is now greater than the value of back. That means our queue is now empty. If back is -1, or the value of front greater than this dot back, then our queue is empty. That way, when we dequeue, we want to return T and an error. Return errors.new, queue is full. Or we need to return a default type for type T. How do we do that? One way to do that is to declare a variable of type T and return that. That solves the problem. After this check, we can dequeue our first value from the front. Remember, the front was 0. We need to dequeue, then increase the value of front by 1. So this dot front plus plus. At this point, we can return res and nil. That is the implementation of the queue. Before we start testing the queue, I would like to add just a helper method for us to be able to dump the items in the queue. So let's implement the string interface. I'll go ahead and create a buffer for, let's call it value error equal to this.dequeue. We are not supposed to take any argument for dequeue, so I'll take out that parameter. If error is not new, we need to break out of the loop. Say that the queue is full. Yeah, if the error is not new, then the queue is full or it's empty. Okay, at this point we have the data, so we can just write it to the buffer by doing write string fonts printf. I'm going to put v and then value. After that, return buff.string. This is the implementation. Time to test it. I'll create a main.go. Open that main.go, package main, func main. Let's create our first queue. Is queue.new. Let's create a queue of integers and queue. The first item in the queue will be 10. Second item will be 11. Third item will be 12. First come, first out. So let's print it. Our queue. We can print queue because we implemented the string interface. Go run main. 10, 11, and 12. We can, I'm not really happy how this is printed because of this one that we have here. That's what is causing it to print that way. So we print it again, 10, 11, and 12. We can try to demo the idea of expanding the queue. Where is it? So we have 10 items. So we can print a message out here that expanding queue. To test it quickly, we can do it for I equal to 0, I less than equal to, let's do it. Let me start from 1 to make it obvious. So we want to enqueue more than 10 items. We can put I times 2. Let's run the code. You see, we have all the items in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 11th one was the cause of that expansion. So our queue, we expanded the queue at this point. If we don't do this expansion, let me show you what will happen. Let's say we take out this code. We are going to receive index out of range exception, index out of range. So it's clear that the importance of expanding the queue at that point, you can see it. So let's take it out now. You can create, at this point, you can create a queue of anything. We can create a queue of type, let's say user, name, string, and you do queue, let's say users, queue.new, user. So imagine if you are loading your users from the database and you want to do something in the order of first come, first out. This is very good data structure for it. Users.enqueue, user name aj. How about making it possible for us to chain the method like this? I'd like to chain it like this. Something like this. Then I can go ahead and print users. Right now it's not working. Let's make it work. We need to return the queue instance, right? So come here and we return this. That allows us to do the method chaining. It's not required, but just make the code a little bit more flexible. At this point, you have our AJ. So the first item in the queue is AJ, followed by MK, followed by AB. Fantastic. Our queue is working. Thank you for watching. If you've not subscribed to my channel, please consider subscribing. I'm building this channel mostly targeting beginners, and I hope you enjoyed this tutorial. If you need more tutorials like this, please do let me know in the comment. Thank you.